Learning target. Given two functions f and g in tabular form, name the domain and range of f, g, f inverse, and g inverse. Sketch the graph of f, g, f inverse, and g inverse, and create a table of new functions created from compositions or inverses of the new functions. That was saying a lot. Let's take this piece by piece. First thing we're going to talk about is the domain and range. We're given two functions here in tabular form. We were given the function f and the function g. Let's focus on the function f first. And the domain of f, that's the inputs, 1, 2, 3, 4. The range of f is the outputs, 5, 6, 7, 8. The domain of the inverse function is simply going to be the inverse maps the outputs back to the inputs of the original function. So it's simply going to be the range of the original function f, which is 5, 6, 7, 8. The range of the inverse functions, remember again, the inverse will take the outputs of the original function f and send them back. So it's going to be the domain of your original function f, which is 1, 2, 3, 4. Let's do the same thing with our function g here. The domain of g, 5, 6, 7, 8. The range, 4, 3, 2, 1. Just writing them in order here, 1, 2, 3, 4. I like to keep my sets in order. But if you wrote it as 4, 3, 2, 1, it would still be correct. But I like trying to keep an order of things. So the domain of the inverse of g inverse simply takes the range of g and maps it back to the inputs of g. So the domain of g inverse is the range of g, which simply equals 1, 2, 3, 4. And the range of g inverse is the inputs or the domain of our original function. So 5, 6, 7, 8. Let's look at the graphs. First we're going to look at the function f, and we're going to look at, alongside of f, we want to look at its inverse function, f inverse of x. So again, since f maps 1 to 5, f inverse sends 5 back to 1. 3 goes to 7 with f inverse sends 7 back to 3. So here is the graph. Since I've got in blue here, I've graphed f in blue. That is 1, 5, over 1 up 5, 2, 6, over 2 up 6, 3, 7, over 3 up 7, over 4 up 8. And now let's graph f inverse. We see here in red, f inverse, 5 goes to 1, 6 goes to 2, 7 goes to 3, and 8 goes to 4. And with the line y equals x, we threw that in here to see that symmetry. The relationship between the graphs of f and f inverse of x is that f inverse is a direct reflection over the line y equals x, and vice versa. So directly reflect over that line to get the points. So that point reflects over the line to get to that point. Similarly, let's do the same thing with the graphs of g and g inverse. So here's the graph of g. We see 5 gets mapped to 4, 6 gets mapped to 3, 7 gets mapped to 2, and 8 gets mapped to 1. And here in red we have g inverse. We see that 1 gets mapped to 8, 2 gets mapped to 7, 3 gets mapped to 6, and 4 gets mapped to 5. And again, let's put the line y equals x in there to see that relationship of the reflection across the line y equals x. So this point corresponds to that point, reflects directly across. This point reflects across the line y equals x to get this point. Creating tables is the last thing that was in our target. So let's create a table here. Let's look at the functions f and g. And let's create a table for f composed with g. Now it's very important here to figure out what the domain of this function is. And it's always going to be the domain of this first function g here, because we have to put when things go into this composition f composed with g, the first thing that happens is they run through g. So it can only take on values. So f composed with g can only take on values that g can take on. So the domain of f composed with g is the domain of g, 5, 6, 7, 8. And to see how this works, G5 gets sent into G, so 5 gets sent to 4, and then you take f of 4. 4 gets sent to 8. So f composed with g of 5 equals 8. Let's look at f composed with g of 6. So we see where does g send 6? G sends 6 to 3. And then we go back to see where f sends 3. F sends 3 to 7. So f composed with g of 6 equals 7. And similarly here, g sends 7 to 2. And f sends 2 to 6. So f composed with g of 7 is 6. Let's look at 8. Let's see. So when we plug 8 into f composed with g, it goes into g first, so g sends 8 to 1. So then we're looking at f of 1. So f sends 1 to 5. And there's our table for the composition of f and g. Let's look at one more table here, a very important table. We have the function f and the function f inverse of x. To create this table, first of all, we have to figure out what the domain is. Again, when I do f composed with f inverse of x, the first thing that happens to numbers that are put into this function is they have to run through f inverse. So this function can only take on numbers that f inverse can take on. So my domain has to be 5, 6, 7, 8. That is the domain of f inverse. So there's my domain. Now if we look, when we plug 5 in here, the first thing we do is f inverse of 5. So f inverse sends 5 to 1. And then we have to do f of 1. And f sends 1 to 5. Thus we have f composed with f inverse of x, f inverse of 5 equals 5. What about 6? F inverse sends 6 to 2. And f sends 2 to 6. So we have f composed with f inverse of 6 equals 6. What about 7? F inverse sends 7 to 3. F sends 3 to 7. So we have f composed with f inverse of 7 equals 7. And 8. F inverse sends 8 to 4, and f sends 4 to 8. So we have 8. And if we look here, this is the identity function. We should know that f composed with f inverse, if we have properly defined, if f is indeed invertible and f inverse has been properly defined, when we compose those two functions, we should have the identity function, I of x equals x. That is, when we plug something in, 5 goes in, it should spit out a 5. 6 goes in, it should spit out a 6, 7, so this should appeal to what we've already learned about composition. Should return the identity, well, it has to return the identity function. Composition of a function and its inverse must be the identity function if we have done our work correctly. And that ends this video lesson. Thank you.